countdown.
Congratulations! This live broadcast is specially brought to you by Academy YouTuber Malaysia, an initiative by Didik Malaysia and Kelab Guru Malaysia. Please pay attention. The live broadcast will begin shortly. The link to the certificate of attendance will be provided at the end of the session. Please make sure it is filled within the stipulated time. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum. Good evening and hi to all the teachers, parents and the wonderful students. Welcome to Pusat Tuisyen Academy YouTuber, a joint venture with Didik and Kelab Guru Malaysia with the hashtag bermula percuma, selamanya percuma. Okay, before we proceed, let's begin our session with the recitation of Kitab Al-Fatihah. And for the non-Muslim, please take a moment of silence. Okay, how is everyone doing today? My prayer is that everyone is in the best of health and ready to proceed with today's class. So let me introduce myself first. I am Madam Rosmaya, okay, as your moderator and also a control host for today. I am a Form 6 Physics teacher at SMJK Yuhua, Kajang, Selangor. And the most important person today is our presenter, Teacher Nun. She is from College Matrikulasi Negeri Sembilan. So let us give a warm welcome to our presenter. Okay, even though there are only two of us, but we will make sure that today's session runs smoothly. Okay, for the record, we are now live on Teacher Nun channel. So as a sign of support to Teacher Nun for the hard work in preparing today's lesson, so please subscribe her channel and not forgetting my channel too. Okay, as usual, the lesson will last approximately 1 hour. Okay, the certificate link and the credit claim link will be given at the end of this session. So remember that you can only use EDD email or MOE email to claim the certificate. So for credit claim, you need to collect one letter and 5-digit codes. Okay, I repeat, one letter and 5-digit codes. So which will be announced separately 3 times, okay, during our class today. So be sure to follow the class up until the end to get the complete code for the credit claim. Okay, I would also like to remind students to use appropriate language and also use appropriate profile picture if you wish to post comments in the chat box. So I'm pretty sure all of the students here are excellent students who will uphold a positive classroom environment. So please give your full cooperation in making this class a lively one. So stay focused, and if you have any questions, so please write on the chat box and Teacher Non will try to provide you with the answers. So before I pass this session to Teacher Non, okay, I will announce the letter and the first 2 digits code for credit claim. Okay, listen carefully. So the codes are A19, A1 and then 9. Okay, so without further ado, please welcome Teacher Nun, okay, to start her presentation.
Okay, bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh. And good afternoon, everyone. So, how's everyone today? So, I hope that everybody in the good health and good situation. Okay, as usual, we will continue our tuition class today. Okay, but before that, I just want to introduce you the Academy YouTuber team. So, it is a lot of advantage, right? So this is the physics teams, okay, for the STPM and matriculation, lead by Madam Rosmaya. And this is all the teachers, which is Teacher Su, Teacher Hapsahayu, and also me. And then we have the mathematics team, which is lead by Teacher Im, okay. And then we also have biology prayu team, lead by Cikgu Faiza. And for the chemistry, lead by the Cikgu Shahnun. And for the Perakaunan and Ekonomi Prayu team, lead by Madam Fizi. Okay, so the Academy YouTuber also have apps that you can download from Google Play. It is a lot of video, education video there, and also the physics video you can get from these apps. Okay. All right. So now we will start our discussion. So for today's class, I will discuss about topic 3, which is about the electric current and direct current circuit. So because of this topic is quite long, it is divided by there are 9 subtopic. So I divide by 2. So for today's, I will discuss the first part, which is consists of subtopic 1 to subtopic 5. Okay. So, and at the same time, the first part I will discuss the concept that relate to this topic. After that, we do the exercise given to you before this. Okay, so I hope that you have tried the solution and you can check your answer. Okay. All right, now take a look at the conceptual part. So for the first subtopic, which is about the electrical conduction. So I just summarize the what you're supposed to learn from each subtopic. Okay, for the electrical conduction, so first you need to know how to explain the microscopic model of current. So how the production of the current. So in this case, first take a look at the this is the image, a figure for the inside the conductor. So inside the conductor, there is a metal atom, or and also free electron. So initially the free electron move randomly in the metal with the random velocity represented by VR. This is what happened inside the conductor or a metal. Okay, so when we connect to the power supply or when we apply the electric field, okay, between the both end of the conductor, the free electron will experience the electric force, cause the free electron to drift, okay, with the drift velocity Vd towards the positive terminal. Okay, why to the positive terminal of the battery? Because of course electron attract to the positive terminal. So all the free electron drift with the drift velocity Vd. So in this case, the drift velocity is less than the random velocity because of they are arranged to they are drift to the positive terminal. Okay. So when the electron drift to the positive terminal, so the current will flow inside the conductor. So for the current that produce in flow in the conductor because of the motion of the free electron, so we can define the electric current as the electric current, the rate of change of the rate of charge flow. Okay, the rate of charge flow, or we also can say the total or the net charge Q flowing through the area per unit time. So the equation for the electric current is given by dqi is equal to dq per dt. The unit for electric current is A, ampere, or we also can state coulomb per second. So sometimes we also can calculate using the first definition, which is Q over T also. And we have the quantization of charge, which is Q is equal to NE, where the N is represent the number of electron, okay, and E is the charge of the particle. Okay, so that's the what you're supposed to learn in the electric conduction in the first part. Okay, the second part is about the Ohm's law and resistivity. So for the Ohm's law, it stated that the potential difference across a metal conductor is proportional to the current flowing through it if its temperature is constant. So this is very important for the law. We're supposed to have one constant. So in this case, when the temperature constant, so we said that the V is directly proportional to the I. Because of that, V is equal to IR. Okay, and for the resistivity, so resistivity is defined as the resistance of a unit cross-section area per unit length of the material. So given by the equation of resistivity, the symbol is rho, and it is equal to R A. R is the resistance, A is unit cross-section area, and L is the length of the material. And the unit for the resistivity is ohm meter. Okay. The third part in this topic, it is about the variation of resistance R with the temperature. So we know because of V is directly proportional to the I, okay, from the Ohm's law. So R is constant, referring to the temperature is constant. But what happen if the resistance is increased, or if the resistance change? Of course, the temperature will also change. So what is the relationship between the resistance and the temperature? So in this case, we will see what happened when the temperature increase. Okay, what happened to the resistance in the metal when the temperature is increased? Okay. So it stated that when the temperature is increased, okay, the resistance in the metal will increase. So why this is happen? Okay, can you please listen carefully? So it is like this: when the temperature is increased in the metal or in the conductor, kinetic energy of the metal ion also will increase. So when the metal atom have a kinetic energy, it will vibrate. Okay, it will vibrate and collide with the free electron. But the main point is the vibration of the metal atom is increased because of the temperature is increased. So this will cause the free electron less flow because of the space between the the space between the metal atom is decreased because of the metal atom now vibrate because of the temperature is increased. You get what I mean, right? Temperature increase, the metal atom will vibrate. We know that a lot of collision happen either between the vibration of the metal atom with the metal atom or collide with the free electron. But when they collide with the free electron less flow, less move because of the space now consists of the vibration of the metal. A lot of space is referring to the vibration of the metal atom. So when the electron less flow, so the current is decreased. Am I right? Because of we define the current just now, the rate of charge flow. So when the less charge flow, less electron flow, so the current will decrease. Okay. So what happen when the current decrease? The resistance will increase. Okay, that's actually the point that you're supposed to know. Why, when the temperature is increased, the resistance is increased. So from this concept, we can have the relationship between the resistance of the metal with the temperature. So the relationship is given referring to the equation. Actually, we refer to the temperature coefficient of resistivity alpha, and the equation we can write down as R, which is the resistance at the final temperature, for example, equal to R naught, which is referred to the initial resistance times with 1 plus alpha. Alpha is referred to the temperature coefficient of resistivity for the conductor, and T is the final temperature minus with initial temperature. Do take note that normally when we talk about the change of temperature, it is supposed to be, or change of any physical quantity, it's supposed to be final minus initial. So in this case, we want to find the final resistance of the metal because of the increasing of the temperature. Later on, we will see application, the equation that relate, how we apply the equation. The fourth part in this subtopic, or the fourth subtopic in this chapter, is about the electromotive force. Normally, we call it EMF, and the internal resistance, and also the potential difference. Okay, there are three things here: electromotive force, internal resistance, and also the potential difference. Okay, so first take a look at the figure. The figure consists of the battery. Inside the battery, there is a internal resistance R. Okay, and then there is a external resistance represented by capital letters of R. Okay, so referring to this circuit, you can see the current flow from the positive terminal through the external resistor and back to the negative terminal, or back to the battery. Okay, so in this case, if you look at the battery, the EMF of the battery is defined as the energy provided by the source or by the battery to each unit of charge that flow through the resistor, internal resistance and external resistance. So capital letters of R represent the external resistance. So EMF provide the energy to each unit of charge that flow in the circuit. Okay, that charge flow through the external and also internal resistance. Okay, but okay, if we want to define the potential different, what is the different? So V is defined as the work done in bringing a unit test charge from the negative to the positive terminal of the battery through the external resistor only. Okay, so actually the work done is also, if you refer to the work energy theorem, it is also actually relate to the energy. So V is relate to the work done, okay, in bringing the charge through the external resistor, external resistance only. Okay, so do differentiate between the definition. Actually, the definition is equal. Only the charge that flow in the circuit. Okay, and we also can define the internal resistance. So what is internal resistance? Internal resistance is defined as the resistance of the chemical inside the battery between the pole. Okay, between the poles of the battery. Okay, that's the internal resistance. Okay, sometimes we ignore the internal resistance is negligible, but in this case, because of we need to know what is the effect of the internal resistance in the circuit, because of it's relate with the EMF and the potential difference, so we will consider the internal resistance. And there are few factors that influence the internal resistance, which is here I give you four, which is the first one is the chemical properties of the battery. So, and then the temperature of the battery, the size or the distance between the electrode in the battery, and also the age of the battery. That's why sometimes if we use the battery too long, finally the battery will not function anymore. Okay, and the relationship between the EMF, the potential difference, and the internal resistance can be shown as in the equation given, which is we call it terminal voltage V, or the potential difference V, is equal to the EMF minus with IR. Actually, the basic concept is the EMF, which is equal to the V passing through the R, the current that passing through the R, plus with the current passing through the internal resistance. So when we rearrange, we have the terminal voltage, the equation called terminal voltage or potential difference as EMF minus IR. And IR, we also call it voltage drop. So let's say if the question state that you need to calculate the voltage drop, so the equation that you're supposed to use is V is equal to IR, meaning that the potential difference across the internal resistance only, okay, when the current flow in the circuit. Okay, and the last part, okay, for this topic, not last part, the fifth part, because as I said, there are 9 parts, right? I divide by 2. So the fifth subtopic is about the resistor in series and parallel. So I really want you to remember, before this we discussed about the capacitor, the arrangement of the capacitor. Still remember? So the arrangement of the resistor is also as the arrangement of the capacitor. So the first part is the series arrangement of resistor. So in this case, I just represent by R1, R2, and R3. Okay, and this is series arrangement, and here are the parallel arrangement. And how we want to differentiate either series or parallel, we also refer to the current flow. If the current flow through each resistor is equal, so it is a series combination. But if the current flow and then the current is divided at the junction, so it is a parallel arrangement. So for this series and parallel arrangement, you will see the relationship between the R, V, and I, referring to the Ohm's law. And for the effective resistance of the arrangement of the capacitor, for the series arrangement, for the effective, we need to add all the resistance inside the circuit. Okay, but for the parallel arrangement, the equation for effective or equivalent resistance is equal to 1 over R is equal to 1 over R1 plus 1 over R2 plus 1 over R3. And then for the V, same with the capacitor. For the parallel arrangement, the potential difference is equal across each resistor. So we can say that the total voltage or the voltage supply or voltage apply or the battery is equal to the voltage of the source is equal to the voltage across the R1, R2, and R3. Okay, the voltage is equal. But for the series arrangement, we need to add each voltage, so it will equal to the total or applied voltage. For the current, okay, it is opposite the potential difference. So for the series arrangement, because of the same current flow through each resistor, so the amount of current is equal. Okay, because of the same current flow. But for the parallel, because of the initial current or the total current divide by 3 in this case because of the arrangement of the resistor. So we need to add the current at each junction. Okay, so we get this relationship. So actually, this relationship is very important when we want to solve the question that relate to the combination of the resistor. Okay, so that's the concept that what we will discuss in our exercise after this. Yeah, so now we go to the exercise, the problem solving. Okay, take a look. Have you tried to answer the question? So the first question, take a look at the first question. So figure shows a metal wire carries a current of 5.5 ampere. What you need to determine? So first you need to determine the number of electron per second passing through the wire, and also you need to determine the amount of charge flow through a cross section area of the wire in 1 minute. So here I write down the information given from the question. We just have the info which is the current flow, which is 5.5 ampere, and also hidden information because of it stated it is about the electron. So we have the charge of electron 1.6 times 10 power negative 19 coulomb. So where you get this amount, you can refer to the list of selected constant given to you. Okay, do take note that it is, even it is just state electron, but you have uh, the hidden information. Okay, so how you want to solve, how you want to calculate the number of electron per second, because of if you, it is less information from the question, right? So because of this is the number of electron per second. Okay, normally I will write down first what we want to determine, so that we will get the idea which equation that we want to use. So when we talk about the motion of the electron, so of course it is related with the current, am I right? So referring to the definition of the current, electric current, which is equal to Q over T, we start with that one. You know that when the electron flow, meaning that it is related to the current. So the equation for the current flow or electric current is Q over T. And from the quantization of charge, Q is equal to NE. Then you can see here, we can calculate the number of electron per second, N over T, by substituting the information that we have. So in this case, the current is 5.5 and the electron is 1.6 times 10 power negative 19. So when you calculate the number of electron per second, you will get the answer, which is 3.44 times 10 power of 19 electron per second. Okay, do take note the unit because of N is the number of electron, T is second, so per second. And for B, we want to calculate the amount of charge. So in this case, it is quite easy, right? Because of you need to calculate the amount of charge in 1 minute. But remember to use the SI unit. So for 1 minute, it is equal to 60 seconds. So change the T to the 60 second. So because of that, what you will get? What is the answer for Q? Anyone have tried this question? Ada cuba tak? Okay, if you have tried, just write down your answer in the chat box. Okay. All right. So the Q, the amount of charge is equal to 330 coulomb. Okay, this is the application of equation for the electric current and also the quantization of charge. Okay. Now we go to question number 2. So for question number 2, so this question is quite special. And this is past years. I'm not remember which session. So it states that figure shows a cable of 850 meter long consists of an insulated core A, or insulated core meaning a conductor A with a cross section area of 100 millimeter square, and 6 other insulated conductor B, okay, with the same cross-section area. Given the resistivity of conductor A, which is 6 times 10 power negative 7 ohm meter, and the resistivity of B, which is equal to 2 times 10 power of negative 2 times 10 power of negative 8 ohm meter. So this actually, if you look at the cable, it is quite rare for us. There are seven conductor inside a cable. But if you search, if you want to understand how is it, so it's just like this lah. But this is not exactly the cable, but the arrangement is like this. This is the real picture lah. Okay, and uh, when you read the question, as usual, just list the information given. You use the subscript to represent because of there are two types of conductor, right? A and B. Okay, and for the A, if you look at the question, are the conductor A and B in series or parallel to each other? So can you think either it is parallel or series? If you look at the diagram, it is actually because of if we connect at both end with the battery or with the power supply, so it show that the arrangement is parallel arrangement. Okay, am I right? You will need to identify series or parallel, and then you need to determine the resistance of the core A, and then total resistance of the six conductor B, and then resistance for the whole cable. All right. So we talk about the resistance. So as I said just now, because of referring to the arrangement, these cable are arranged in parallel to each other. Okay, and then for B, we want to determine the resistance of the conductor A. So we use the equation of resistivity. We just rearrange the equation for the resistivity, which is rho A L over A. Initially, rho A is equal to R A over L. So we just rearrange, and you will get the resistance of the conductor A, which is equal to 5.1 ohms. Okay. And then for C, we need to calculate the total resistance of the six conductor B. So before you calculate the total resistance of B, what you need to do first? You need to calculate the resistance of the conductor B. Am I right? Same thing like A. So first calculate the resistance of the conductor B. Okay, and because of we know that the conductor B is arranged in parallel. So to calculate the total resistance for for the conductor B, so what we supposed to do? We use the parallel arrangement of the resistor. Okay, which is the sum of RB, meaning that total for the six conductor B is equal to 6 times 1 over RB lah. Actually 1 over RB plus 1 over RB until 6. So I just simplified the equation. Okay, and I substitute because of we have calculated the RB, the resistance for each conductor B, 0.17 ohm just now. We just substitute and you will get that the sum or the total resistance of the six conductor B is equal to 0.028 ohm. So this is quite question because of you need to identify the arrangement. If you say that it is a series totally, you will get wrong answer. So please be careful and do a lot of exercise so you can see the variation of the question. Okay. And lastly, to calculate the resistance of the cable, meaning that we need to combine the resistance of the cable A, the resistance of the conductor A with the B. And as stated, A and B are also arranged in parallel. So what to do? We use the parallel arrangement equation for the effective resistance. Or here I just represent by R cable. So it is 1 over RA. Because of RA, the resistance is different, and 1 over the sum of the resistance of conductor B. And if you calculate, you will get that the resistance for the resistance for the cable is 0.0278 ohm. Okay, and it is correct, right? Because of the resistance for the parallel arrangement of the resistor is less compared to the series arrangement. Okay, so this is the solution for question number 2. Now we go to the question number 3. Okay, referring to the question number 3.
Teacher
The,
Non,
yes. Oh, my
we,
that's
we
fine.
have we have already go live for about 30 minutes. So would you like to take a break now?
Okay.
Okay. So before we take a break, I will announce the third digit code. Third digit code for the credit claim. So listen carefully. Okay, everyone. The digit is number 7. Okay, the digit is number 7. So okay, stay tuned everyone, and let's watch the advertisement for a break.
Berita baik untuk semua. Kini, Akademi YouTuber memperkenalkan sistem mata ganjaran kredit AYU untuk dikumpul. Jom ikuti kelas tuition live AYU untuk mengumpul kredit AYU dan berpeluang menebus hadiah-hadiah yang menarik. Hadiah bernilai lebih RM10,000 disediakan secara percuma untuk pelajar seluruh Malaysia. Apa tunggu lagi? Tebus ganjaran hebat ini sekarang. Layari www.academyyoutuber.com untuk maklumat lanjut.
Okay, welcome back students. Teacher Non, you may continue with your questions.
Okay, thank you so much, my dear Rosmaya. Okay, so take a look at question number 3. The heating element is made of 1 meter long wire with cross-section area of 3.1 times 10 power of negative 6 meter square. The wire has resistivity of rho naught, which is equal to 6.8 times 10 power of negative 5 ohm meter, and inertial temperature of 320 degrees Celsius. Okay, if you look at the information, I just list everything here. And the temperature coefficient of resistivity, alpha, is equal to 2 times 10 power negative 3 per Kelvin. So first we want to determine the initial resistance of the heating element, and then we need to calculate the resistance at an operating temperature of 420 degrees Celsius. This is the part of the effect of the temperature with the resistance. So you want to see what happened to the resistance when the temperature is increased. All right. So because of that, first we want to calculate the initial resistance of the heating element. So if you have no idea how to calculate the initial resistance, because normally for the resistance or for the current, we have the Ohm's law, right? V is equal to IR, but the information is not here. But if you see the given information, there is L, A, and rho. So from the resistivity of the heating element, we can calculate the initial resistance. So because of that, we can use the equation of R naught equal to rho naught L over A. We just need to substitute the value inside the equation. Okay, please substitute correctly with the correct SI unit. And then if you calculate, you will get the answer, which is equal to 21.94 ohms. Okay, this is for the initial resistance of the heating element. Okay, for question B, you need to determine the resistance of at an operating temperature of 420. So our initial temperature just now is 320 degrees Celsius. What happens when the temperature is increased to 100 by 100 degrees Celsius? So how we want to calculate? We just use the relationship between the resistance and the temperature. Okay, we want to find the final resistance. So it is equal to R naught. Okay, as shown the equation, and you need to substitute correctly. Initially, I've calculated the initial resistance, 21.94. We just substitute in this equation. Okay, and then the coefficient, temperature coefficient of resistivity is 2 times the power of negative 3. Substitute in the equation, and the final temperature is 420, and the initial temperature is 320. So if you calculate, okay, can you guess the answer? So the answer is 26.33 ohms. So you can see initial resistance is 21.94. When the temperature is increased, so the resistance of the heating element is also increased to 26.33 ohms. Okay, so the relationship is correct. And you can actually, you also can check your answer. Supposed to be increased compared to the initial resistance. Okay. And then we go to the question number 4. So for question number 4, a wire of unknown composition has a resistance of 35 ohm at 20 degrees Celsius. Okay, because of this is when I list, I just represent it by the R naught and of course T naught. When the wire is carrying a current, heat produced by the current cause the temperature of the wire to increase by 37 degrees Celsius. Okay, you need to read the question carefully actually. Please read carefully because of in this case, I repeat again, heat produced by the current caused the temperature of the wire to increase by 37%. What does it mean by What does it mean? If by meaning that the increasing of the temperature is 37 degree, meaning that the change of temperature is equal to 37 degree. It will be confused. Sometimes if you not read carefully, you will assume it is the final temperature. If you said it is final temperature, so when you calculate the change of temperature, of course it is different, right? Kalau if you assume it is a final temperature, so when you want to calculate the change temperature, so change 37 minus 20, it is equal to 17, the change of temperature. So totally out. See, if you even know use the equation but you not read the question carefully, you also will not get the correct answer. So please be careful to read the question given to you carefully. And in this case, you need to calculate the change in the wire resistance. Change in the wire resistance. Actually, in the real question, normally I will highlight the what we supposed to calculate in the question. Okay, so in this case, we are alert. You want to find the change in the wire resistance, and given the coefficient of the temperature coefficient of the resistivity of the wire, which is 6.8 times 10 power negative 3 per Kelvin per degree Celsius. Okay, so how you want to solve this question? We want to find the change in the wire's resistance delta R. Of course, the equation given to us or the equation that given to you in the list of set formula is R equal to R naught 1 plus alpha change of temperature. So if we rearrange the equation, so we get that R naught plus R naught alpha delta T. Why we need to rearrange the equation? Because of the given in the question given the change in temperature. Okay, change in temperature which is 37 degree. So and we want to find the change in the wire resistance. So kalau for the change of wire resistance which is R minus the equal minus with R naught. So we want to find the change in wire resistance. Because of that, we just need to substitute the R naught, alpha, and also the change in temperature, which is 37 degree. So in this case, the initial temperature is, we not use the initial temperature. It is only the disturbance for this question. So please be careful. And if you calculate, you will get the change in wire resistance is equal to 8.81 ohm. Okay, so this is the types of question that they can ask, referring to the application of the equation of the effect of temperature to the resistance of the conductor. Okay, and then we have question number 5. All right, so question number 5, this is about the EMF, internal resistance, and also the potential difference. So a 12-volt battery has an internal resistance of 10 ohm, is used to light a bulb of 160 ohm, which is connected in series to a resistor of 50 ohm, as shown in the figure below. So there are external resistance. We also have the resistance of the light bulb. Okay, if a voltmeter connected to the terminal of the battery, okay, as shown in the figure, what is the reading of the voltmeter? We want to know what is the reading of the voltmeter if this situation for this circuit. So first, as usual, list all the information given from the question and identify what you want to calculate, which is the reading of the voltmeter. So where you want to start? So what you can start? So first, because we want to find the reading of the voltmeter, if you look at the external resistance R and also the light bulb, it is arranged in series. So first you can calculate the resultant effective resistance in the circuit. Okay, for the external resistance, which is it is equal to 210 ohm. Okay, for the external resistance. Okay, and then we can use the equation of the actually terminal voltage equation, V is equal to epsilon minus IR, but I just rearrange. Okay, because of it is easier for us to identify, the EMF is equal to V potential different across the external resistance plus with the potential different across the internal resistance. Okay, and because of that, I just because of V is also equal to IR for the external resistor, external resistance, our external resistance. So we can write down like I R plus R, and when we substitute, because of our external resistor, external resistance is equal to 210. We have combined both in series combination, 210 plus 10. So we can calculate the current first. Okay, the current flow in the circuit, the amount of current flow in the circuit. That's our first step. Okay, and now we can calculate the reading of the voltmeter by using the Ohm's law, which is V is equal to IR, and the current flow in the circuit. Actually, this current also flow inside the internal resistance. Okay, also flow in the internal resistance, and in this case our R now, because internal resistance is 10, internal resistance is 10, so we add on all the resistance, and the resistance, the light bulb, internal resistance is in series, so it is equal to 220, so times with the current flow, you will get that the potential difference across the EMF is equal to 11.55 volt. Okay, that's the reading of our voltmeter. Okay, and now take a look at question. Sorry. Okay. Oh, all right. But it is question number 6. Okay, for question number 6, okay, if you look at the arrangement, we just put the Swiss. Okay, the difference is there is a Swiss here, and also the ammeter. Of course, the function of ammeter is to determine the reading of the current flow in the circuit. Okay, referring to the question, figure above, shows a battery of EMF 6 volt. Okay, and internal resistance of 0.5 ohm is connected to a resistor of resistance 32 ohm. Okay, we need to determine the reading of ammeter and voltmeter when the Swiss S is open and when the Swiss S is closed. Okay, do take note that there are two things we want to calculate for these two cases. The first, when Swiss S is open, what is the reading of ammeter and voltmeter? When the Swiss S is closed, what is the reading for ammeter and voltmeter? Okay, now we take a look at the Swiss S when we open the Swiss S. So what happened? If the Swiss S is open, there is no current flow, right? Supposed to be no current flow in the circuit. So ammeter will show zero reading. Okay. But for the voltage, for the or for the voltmeter, so voltmeter, because of there is no current in the circuit, but voltmeter will measure the potential difference across the battery supplied by the battery, which is equal to the EMF of the battery, which is 6 volt. Okay, for the voltmeter reading. So this is when the Swiss S is open. So what happens when Swiss S is closed? So what is the reading for the ammeter and voltmeter? Okay, when Swiss S is closed. Okay, you just need to imagine the Swiss is closed. So referring to the equation of EMF, which is equal to potential difference across the external resistance plus with potential difference across the internal resistance. Okay, the same equation as the terminal voltage. So when we substitute the EMF, okay, which is 6 volt, and the current represent the reading of the ammeter. So we want to calculate the current, and the external resistance R is 32 and the internal resistance is 0.5 because of the current will flow through in the circuit when the Swiss S is closed. So from here you will get the reading. The reading of ammeter will show 0.185 ampere. Okay, that's the reading of ammeter. Sorry. So that's the reading of ammeter. And how about the reading of voltmeter? So because of we know the current flow, okay, to calculate the voltmeter reading, so it is equal to EMF minus with IR. So the EMF is 6 volt and the I current that we have calculated or the reading of ammeter just now is 0.185 times with the internal resistance 0.5. This is the voltage drop. We call it voltage drop. So we will get that the voltmeter reading is 5.91 volt, meaning that if there is no current flow in the circuit, the voltmeter will give the same reading with the potential difference or the EMF of the battery. But when the current flow in the circuit, which is when the Swiss S is closed, So what happened is there is a voltage drop through the internal resistance. Okay, that's why the voltage for the reading of the voltmeter is decrease less than the EMF. It is not equal to the EMF anymore. Initially, it is equal to EMF because when the current flow, the current also flow in the internal resistance. So there is a voltage drop there. That's why the amount of the voltmeter reading shows less than the initial reading. Okay, and then we go to the question number 7. So for question number 7, okay, if you look at the arrangement, figure shows a circuit consisting of battery with the EMF and internal resistance of 20 volt and 1 ohm respectively as connected to resistor of 5 ohm, 7 ohm and 9 ohm. Okay, so if you look at the figure, R internal resistance is 1 ohm. Okay, and the another 3 is the external resistance. So calculate the current flow through the 7 ohm resistor. Okay, we want to calculate the current flow through the 7 ohm resistor and also the potential difference between the point X and point Y. All right. So in this case, first we want to calculate the current flow through the 7 ohm resistor. If you look at the arrangement of the resistor in the circuit, this is the series arrangement, right? Between the external resistance, external resistor, and also the internal resistor. So it is a series arrangement. So for series arrangement, we refer to if I do it directly, I calculate directly the effective resistance, which is we add all the resistance in the circuit when we want to calculate the current flow. Because of the EMF is given as 20 volt, so you just need to substitute EMF 20, and then effective resistance is 22. When you calculate the current, you will get 0.91 ampere. Okay. So this is the current flow through the this is the current flow in the circuit. But what is the current flow through the 7 ohm resistor? If you give your answer like this, you will get no marks yet. You need to declare following the question, what the question asks. Because of that, maybe you need to write down the statement, or maybe you need to write down the answer, which is for series arrangement of the resistor, current flow is equal. Because of that, the current flow through the 7 ohm resistor is 0.91 ampere too. You need to state either after you calculate, when you get the I is equal to 0.91 ampere, and then you make a statement showing that I flow through the 7 ohm resistor is 0.91 ampere. You're supposed to answer the question asked. Okay, mesti, you must. If not, if like this, maybe you just get the concept marks. Okay, you not get the marks for your final answer. Your final answer must refer to the question asked. Okay, and for B, we want to calculate the potential difference between point X and Y. So Vxy, okay, we can calculate the potential difference across Vxy, referring to the what is inside the between these 2 points. So in this case, we have the EMF, which is 20, minus with the voltage drop, because we know the current flow through the internal resistance. The current flow is 0.91, the internal resistance is 1 ohm. So because of that, you will get uh, the potential difference across point X and Y equal to 9.09 volt. Okay, actually, if you calculate, you're using the external resistor here, you calculate the external resistance, the effective of resistance of the external resistance, you will get the same answer, either one. So easier if you use this concept. Okay, and then we go to the question number 8. Oh, this is the statement. Just no need. If you because of here you have represent V, that you calculate this V between the point X and Y. So I just take note here. If you look at Vxy is less compared to the EMF of the battery, because of there is a voltage drop through the internal resistance. The voltage drop only occur when the current flow in the circuit. Let's say if you put the switch and you open the switch, so the potential difference across across point X and Y is equal to EMF. Okay, can you differentiate that? You get the idea, right? If the switch is closed, then there is a voltage drop through the internal resistor. if the switch is open, there is no voltage drop because of the current not flow. The potential, the voltmeter will measure the reading, same with the EMF of the battery. Okay, and then for question number 8, if you look at the arrangement, it is a quite simple arrangement of the resistor, which is a battery with an EMF of 15 volt is connected to the 3 resistor as shown in the figure above. Okay, so we need to calculate the effective resistance and also the current that flow through the R3. So through the R3, what is the current flow through the R3? Because of here is the arrangement is parallel arrangement. Okay, first we calculate the effective resistance. So we referring to the circuit given, we just identify R2 and R3 are in parallel. Okay, R1 with the R2 and 3, when we combine this, it's become one resistor which is R23. So R1 and R23 are in series. Okay, or I can simplify the circuit like this. After we combine R23, which is in parallel, so we get the circuit. And we want to calculate the effective resistance. Okay, so to calculate the effective resistance, first because of R2 and R3 are parallel, we just do the calculation for the parallel arrangement. So you get the R23 which is equal to 2.4 ohm, and because of R1 and R23 just now is in series, we use the equation for series combination R1 plus R23. So you will get the effective resistance for the circuit is 7.4 ohms. So this is direct question. You can identify clearly the parallel arrangement because of the current will divide into 2 at the junction. So now we want to calculate the I3. So I3 meaning that the current flow through the R3, and if I can show you the flow of the current. So I1 or total current flow in the circuit represented by I1. When it arrives at the junction, it will divide by 2, which is I2 and I3. We just want to calculate the I3. Okay, take a look, listen carefully, right? Okay, so because of that, first, because of we know the total current flow in the circuit, we can calculate the total current is I1, so we can calculate the total current first because of we know the resistance, the effective resistance of the circuit, which is V total is equal to I R effective. V total is represent the EMF of the battery because of connected to the battery. So 15 equal to I1. I1 represent, meaning that I1 is the total current flow in the circuit. So times with the effective resistance, so you will get I1 which is 2.03 ampere. So this is total current. It is not the current that flow through the R3 because we know that from this total current, it will divide by 2. So how many amount of current that flow through the R3? And we also know that, meaning that you need to do it by step. Referring to the arrangement of R2 and 3, which is in parallel, we can calculate the potential difference across the R2 3. Here, the potential difference for the R23 because of I1, the total current now flow in the resistor R23, and we have the amount. We have the amount of the R23. So because of that, we can calculate the V23 potential difference across resistor 2 and 3, which is equal to 4.87 volt. And even we get the potential difference referring to this relationship, we get the potential difference across to 3. We know that the resistor 2 and 3 are in parallel. So if parallel, remember for the parallel arrangement, the potential difference is equal, right? So we know that the potential difference across resistor 2 is also equal to the potential difference across resistor 3. Okay, the amount is 4.87 volt. Then, because we have the idea, we have the V3 now. We have the V3 and then we know the R3. So we can calculate the I3. So referring to the Ohm's law, you substitute the V3 which is 4.87, and then R3 is referred to the circuit for ohms. So you can calculate, you will get that I3 is equal to 1.22 ampere. Actually, the question is quite simple, just to calculate the current through the R3. But the step is you need to go through one by one, referring to the arrangement. And luckily, I just choose the very simple circuit to give you the idea how to apply the concept that I have, the concept that in the table just now about the arrangement of the resistor, either in series or parallel. Okay, that's the function of that relationship. Okay. Now we go to the question number 9. Okay, question number 9. Okay, this is quite trick question. Take a look carefully. 3 identical lamps are connected in series with a battery as shown in the figure. Okay, initially the switch is closed, the switch is open. So the resistance, this lamp is represent the resistance of the circuit lah. So we have like lamp P, Q, and R, and arranged in series. Okay, arranged in series because our switch S is open. Okay, so what happened when switch S is closed? Okay, when switch S is closed, we need to calculate the effective resistance, okay, of the circuit if the resistance of each lamp is 12 ohm. Okay, you want to calculate the effective resistance if each of the resistance of each lamp is 12 ohm, and also we want to calculate when the switch is closed, what happened to the current in the circuit, and you need to explain your answer. So this is quite conceptual. Normally to answer this, we also refer to the quantitative explanation. Okay. What happened to the current? So quantitative explanation. All right. Now first we want to calculate the effective resistance. I know if each resistor, if a resistance of the lamp is 12 volt, you can calculate right directly because of it in series. So what can you write down in the chat box? What is your answer for the series arrangement of the resistor? What is the answer when the switch S is closed? So I show you when the switch S is closed, we close the switch. What happened to the current flow? The current will flow through the P, through the lamp P, lamp Q, and the current will flow through the resistor that closed and then back to the EMF. The current will not flow through the R. Why? Because of the current have choice. There are two junction. The first junction there is no resistance, the second junction there is a resistance. Do you think that the current will flow through the resistance? You too, right? If there is a resistance at that road, you will choose, let's say for example there is an accident or the pokok tumbang or whatever, we will find another way. Am I right? So same thing with the current. So in this case, if you understand this concept, so you will answer for the effective resistance when the switch S is closed, the answer is 24 ohms. Okay, it is a hot question. You need to carefully take a look at the question. Okay, so that's the first answer. And how about the second one? What happened to the current in the circuit? Explain your answer. So this is quite general. What happened to the current in the circuit when the switch S is closed? So first, you can state what you see is the current that not flow through the resistor R, or the current not flow, or no current flow in the lamp R. Okay, no current flow in the lamp R. Clearly show, right, when the switch is closed, as I explained just now. And number two, when the resistance decrease, okay, the current will increase in the circuit. Why? I said why? How do you know the resistance in the circuit is decreased? So you can calculate when the switch open. Meaning that initially before we close the switch is open. So when the switch is open, the current flow through the lamp P, Q, and R, of course. Am I right? Because of the current cannot flow through the switch is open. So if we calculate the effective resistance before the switch is closed, it is equal to 36 ohm. But when we close the switch, just now we calculate it is equal to 24 ohms, meaning that the resistance is decreased. And we know between the relationship of Ohm's law, when the resistance decrease, the current flow in the circuit will increase. Okay, so that's a very important concept. For actually basic concept, we just apply the basic concept, but the higher order thinking skill is there. Okay, now we go to the question number 10. Okay, our last question for today's class. This is quite trick question. Four identical resistors are connected to a battery as shown in the figure. When the switch is open, this is switch, the current through the battery is I naught. Okay, so we want to calculate when the switch is closed, will the current through the battery increase, decrease, or stay the same? when the switch is closed? Will the current increase, decrease, or stay the same? Close the switch. Okay, of course we need to calculate initial current, and also the current after we close the switch, right? Okay, after this. And B, we want to calculate the current that flows through the battery when the switch is closed. Give your answer in terms of I note, because we have no value for the I note. Okay, now we do the first one, A. When the switch is closed. Okay, we will initially lah. Let's say I note is represent the current that flow initially before the switch is closed. Okay, before the close, now the switch is open. So the current flow at this junction, the current will divide into two. So this current will flow through these two resistor, and the current here is also flow through this resistor. And this both resistor are arranged in series arrangement because of the same current flow through both of them. Okay, the same current flow through both of them, and they are identical resistor. So this is series arrangement, and then between them is parallel arrangement. So we can calculate the effective resistance when the switch is open. So actually when switch is open ni, this is the hidden information actually. Even the questions not say that you need to calculate the effective resistance when the switch is open, because we want to compare either it is increase, decrease, or stay the same, right? So you need to calculate first the effective resistance so that you can compare either the current is increase, decrease, or stay the same. So when you get the effective, okay, when you calculate, you understand, right? Because of, as I said, this is series combination, so I just write down 2R. I simplified. And then this another two resistor is also 2R, and they are arranged in parallel. So the effective resistance is referred to the parallel arrangement. So we get, if you calculate, you will get the effective resistance is equal to R. We have no value, just state your answer in R. Okay, now what happens when the switch is closed? So when the switch is closed, okay, like this, I just close the switch. Okay, when I close the switch, what happened? If you look at here, there is the fault resistor is not here. Why? Because of the current will choose, as I said, the current that, of course the current will divide into two, but when the current flow through the first resistor here, and then do the current divide into two here? No, right. The current will choose the way that there is no resistor. Okay, so the current will choose when the switch is closed. So our circuit is just like this. And because of that, if you want to calculate the effective resistance, because of we want to compare the current, right? So here are the parallel arrangement of the resistor. We calculate first the parallel, the effective resistance between these two resistor. I just represent R1. So if you calculate, you will get 0.5 R, okay, in terms of R. And then for the effective, because of this is parallel, and with this one, it is series. So we just add on R1 plus R. So it is equal to 1.5 R. You understand, right? When what happened when the switch is closed? Okay, so we know that we just compare in terms of the magnitude of the effective resistance. This initially it is R, so when the switch is closed, it become 1.5 R. Okay, meaning that the effective resistance, the resistance in the circuit is increased. So what happened to the current? The current will decrease. Okay, the current will decrease, referring to the relationship of Ohm's law. When the effective resistance is increased, when the resistance increase, the current will decrease. So the answer is the current is decreased. Okay, why? You need to explain, right? Okay, this is your explanation. From the Ohm's law, referring to your calculation, of course you need to show the calculation. Even there is no amount given to you, you just can represent by the symbol. Okay, and then now you need to calculate the current flow through the battery when the switch is closed. So what is the current? So in this case, because we also have no value, right? We can use the ratio where the I is inversely proportional to the R. Because of that, for the final current flow when the switch is closed, okay, for when the switch is closed, okay, inversely proportional to the R, 1.5 R, and initial current is represent the effective resistance is R. So you will get that the current that flow through the battery when the switch is closed is equal to 0.67 I note, in terms of I note. So it is a quite simple question actually, but it is a trick, and it's look like that it is a very very conceptual question because of there is no amount given to us, no amount given to you. You just need to calculate referring to the symbol. Okay, so I hope that you need to do a lot of exercise so that you can see how's the question, how they build the question, so that if you do a lot of exercise, you can see the trend of the question nowadays. Okay, so I think that's all for today's class. So thank you for watching. So don't forget to subscribe, like, and share, and also comment so that I can improve my presentation next time. So I wish you all the best, good luck, and stay safe. I give back to Madam Rosmaya. Okay? Yes, Madam Rosmaya.
Okay, with God grace, we have reached the end of today's session. Okay, congratulations to those who are able to follow our session from the beginning till the end. So before we end our session for today, I will announce the fourth and the fifth or last digit code, okay, for the credit claim. So listen carefully, everyone. The digits are, okay, 1, 4, number 1 and then number 4. So all of you, please stop posting your comments for a while. And if you haven't clicked the subscribe button, please do so. Okay, make sure it turns to grey color, not the red color. And activate the icon bell so that you will not miss the next class session. Okay, then if you find that the lesson was beneficial, click like and share to your friends on your social media. So spread and share the goodness. So once completed, type done on the chat box. Okay, before the certificate link and the credit claim link are given as a token of thank you for your dedication in joining the free online class today. Okay, so I will paste the link now. Okay, I post the CJ link and then the credit link for you to claim the credit. Okay, and the username. Okay, so the certificate link and credit claim link are already given in the chat box. Okay, so please take note, the link will end half an hour after this live. So make sure to use the EDD email or the MOE email only to log in. So incorrect email use will not be entertained. So if you haven't got one, please apply. So the link to apply the email, the EDD email is also given in the chat box on top of the chatting box. So if you wish to get more information on the online classes, so go to www.academyyoutuber.com. Okay, to those who haven't joined EDD Junior Telegram, please do so. So once again, I would like to thank all of the students for joining today. And remember that the more classes you join, the more credit you can claim. So feel free to share this free tuition class to your friends and teachers all over Malaysia. So this is a collective effort from all the teachers throughout Malaysia for all the students throughout the country. So thank you too for being a YouTuber Academy supporter too. So I think that's all for now. See you in another session. Okay, ingat hashtag bermula percuma. Okay, selamanya percuma. So Assalamualaikum. Stay safe. Till we meet again next week on the same day, same time on Sunday at 5 p.m. Okay, so bye-bye.
Wow, banyaknya hadiah menarik menanti anda. Wah, kini Akademi YouTuber mengambil inisiatif baru di mana memberikan hadiah-hadiah ini secara percuma. Ya, percuma kepada anda semua. Bagaimana caranya? Dengan mengikuti kelas tuition online percuma Akademi YouTuber sambil mengutip mata kredit, anda dapat menukarkannya dengan hadiah-hadiah yang menarik ini. Tunggu apa lagi? Segalanya percuma. Jangan lepaskan peluang tau. Dah dapat banyak hadiah menarik, takkan nak lepaskan peluang. Layari www.academyyoutuber.com sekarang untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi YouTuber.